Hi, in today's video, we're going to solve inequalities in one variable, and this is section 2.8. If you guys recall, 2.7, it was solving equations. And just a quick refresher, whenever we see the greater than or less than, greater than or equal, we know we are dealing with inequalities. And the main difference between equation and inequality, not only the equal sign versus the greater than or less than sign, it's also the type of the solution. With an equation, the type of solution is discrete, which in other words means it has a number. I have one solution, the equation has one solution, two solutions, it's three solutions, and so on. With inequalities, we have a range of values, and it's not a one solution or two solutions or three solutions. It's not discrete. In other words, we use interval notation to represent the solution of inequality. And this was done before. It wasn't done with rational equations. It was done with quadratic inequalities. Not with rational inequalities, but quadratic. So whenever we see inequality, we're going to remember to use a number line. Now, there are steps right here that will be very useful. Step number 1, factor numerator and denominator if needed. I look at example 1, numerator and denominator are both linear, so there's no need to factor. Step number 2, I'm going to set the numerator equal to 0. So I'm going to take this, equal it to 0, x equals 2, and what does that give me? It's going to give me the zeros of the function. So this value right here, I'm going to put it on the number line, and this is a 0 of the function. What would the denominator give me? The denominator cannot be 0, so this is one of the not allowed values or undefined. So I'm going to put that on the number line as well. And this is right here, -3, and I'm going to put on top of it UND to refer to undefined value. Now, place the zeros and undefined on the number line. We did that. Choose a number from each interval and plug it into the factored form. So I'm going to choose anything from -infinity to -3. And again, this was done before. Let's say I choose -5. I'm going to plug it in the given expression. And right here, it's going to be a -7 over -2, which is positive. And I'm going to do the same thing. I'm going to pick a 0 because 0 it's easy to plug in. 0 plus a 3. And it's going to be a -2 over 3. And this is going to be a negative. And the last one, I'm going to pick 3. 3 minus 2 over 3 plus a 3, which is positive. That's all what I care about. I want to choose what's less than or equal to 0, which in other words means negative. And I'm going to represent my solution as an interval. So the solution will be from -3 all the way to 2. I'm sorry, not a 0, right here. And I'm going to close it because the given inequality says less than or equal. But I cannot close it on 3 because the 3 is undefined. So I'm going to keep it open on 3. So the solution will be -3, 2. If I take example 2, the difference is that the numerator and denominator are both quadratic, so I need to factor them first. And if you use X method, I'm going to show you what we will find. This will be the factored form. So I'm going to do the same thing where I use a number line, set the numerator equal to 0. I'm going to get -4 and 3. And those two are zeros of the function. The denominator is going to give me 2, and 2 is undefined. And I'm going to choose a value from each interval. I'm going to choose a value, and I'm going to plug it in. You can either plug it in into the factored form or the original expression. I suggest the factored form just because it's easier to see the sign. I chose -5. And negative 5 minus 2, negative 5 minus 2, and you're going to get a positive as an end result, negative, negative, positive. I'm not going to do the plugin for all of them, but you guys can try it. And I want to see what I want to choose. Greater than, that means I need to choose the positives. And I'm going to write down the solution as an interval. So it's going to be negative infinity, negative 4. I don't have it or equal to 0, so I'm not going to close it on the zeros. And 3 to infinity.